Good morning, madam. We are from Group 3 presenting our class for BMKU1253 Dynamic and Mechanics. My name is Feng and my group partner is JUN ZHI. Today we would like to present our solution for the assignment. Specific covering question 3, 7, and 11. We will present the fundamental principle we apply and the step-by-step calculation. For question 3, first we need to do the free body diagram. Then we need to find the radius of curvature at point A. So this is the formula. So we need to find the derivative of y equal to negative 0.00625x, and the second derivative of y is equal to negative 0.00625, and the x is given 18 meter. We also to find that the angle of the slope is the formula. So we find that the angle equal to negative 26.57 degree. So next we apply the Newton's second law, which is F equal to ma in two direction. For first direction is tangential, which is mg sine theta, and minus is the friction, and equal to ma. The acceleration is given 3, so we find that the friction force is equal to 1.1 kilonewton. For next direction is the normal force direction, yes, which is mg cos theta minus n equal to ma. So for any acceleration normal with is v square over rho. So this is we find that the Newton force equal to 6.73 kilonewton. Question 7. This is a question. We use the principle of conservation of energy, which is TA plus VA equal to TB plus VB. TA will be the 0 because it's from rest, and VA and VB is the potential energy, which is the formula mgh. So we go to VA minus VB is between the 46, because we set the datum is here 50 minus 4, so become 46. For mg is given that, yeah. So next is TB will become 1 over 2 mv square. So we need to find the v. So we find that the v equal to 30 n over s. Next, we need to find the density s. So we use the projectile motion formula, which is sy equal to sy naught plus v naught t plus 1 over at square. This part is for vertical part, which is sy is 4 plus s sine 30. Sy naught it becomes 0 because it's for origin. Then v naught is origin for the rest, so become 0. For a is vertical part, so it's for become g, so it's 9.81. The final will be like this, but we got two unknown, which is s and t, so we need to find another equation to find the t first. So we use the same formula to find the t for horizontal part. So for horizontal part, a will become 0 because the velocity initial and final is same, and s naught is 0 because it's from origin, yeah. So we can like this, and we find that t equal to s cos 30 over 30. Yeah. So finally we find the S become 130 meter and T equal to 3.75 second.
Good day to Dr. Fadila. I'm Ong and I will going to explain the question 11, which is the last question of our assignment. First, let us understand the system. Road AB is rotating about point A with a given angular velocity of 3 radians per second and an angular acceleration of 5 radians per second squared. At point C, there is a collar which slides along road AB and at the same time it is pin connected to another road CD. And the road CD is rotates about a fixed point D. Now, we begin with the position vector of point C relative to point A. Since the length of AC is 0.75 meters and road AB is inclined at 60 degrees, the position vector is resolved into Cartesian components. This gives RCA is equals to 0.75 sine 60 degree I and negative minus 0.75 cos 60 degrees J. And this will give us this answer, which is 0.6495 I minus 0.375 J meters. Next, we analyze the velocity of point C. First, we consider road CD as a rigid body rotating about point D. Using the rigid body velocity equation, VC equals to omega CD times RCD. And then we will get the velocity of point C becomes VC equals to negative 0.5 omega CDI meter per second, as the length of CD is 0.5 meters and it is vertical. Then for the acceleration at point C, we will use this formula, which is alpha CD times RCD minus omega CD square RCD, and we will get the answer is negative 0.5 alpha CDI minus omega CD square 0.5 J meter second square. Because of the point C is sliding along AB, we must use the relative velocity equation to calculate the VC, which is VC equals to VA plus omega times RCA plus VCA XYZ. The point A is fixed, so its velocity is 0. The relative velocity VCA acts along the direction of road AB. By resolving the velocity equation into x and y components, we can obtain two equations. And after we solve these equations, we will get two unknowns, which is VCA and omega CD. And after we solve the mathematical equation, we will get the answer is VCA is equals to 3.897 meters per second and omega CD is negative 9 radian per second, which is 9 radian per second with clockwise direction. Next, we move on to the acceleration analysis. From rigid body kinematics of road CD, the acceleration of point C is given by AC is equals to AA plus omega RCA plus omega times RCA plus 2 omega times VCA XYZ plus ACA XYZ. And then we substitute all the unknowns by using the information given above, and then we will get the answer, which is this 0.5 alpha CDI minus negative 9 squared 0.5 J equals to 0 plus 1.875 I plus 3.2475 J minus negative 5.8455 I plus 3.375 J plus 11.6910 I plus 20.2488 J plus 0.866 ACAI minus 0.5 ACAJ. And then we need to calculate what is the answer of these two unknowns, which is alpha CD and also ACA. And then by using calculator, at the end we will get the answer, which is ACA is equals to 134.7 meter second squared, and alpha CD is equals to 249 radian second squared with clockwise direction.